Okay, yeah, good evening, everyone. My name is Krishna Dev Yadav, and today I'm going to conduct a mock training on innovative pedagogy in teaching and learning mathematics. So, thank you. Our facilitator is Mr. Diasim Parashar, and I sincerely thank him for his guidance. Uh, Outlines of my presentation is first, I will introduce the training and explain its objectives. Then, uh, we will begin with short and interesting fun activities to make everyone active and focused, curious. After that, we will conduct the main learning activities where participant observes traditional measuring container and discover the mathematical ideas before them. And the next participant will solve worksheets together to strengthen their understanding. Then we'll have our reflection sessions where everyone shares what they learned, and finally we conclude the sessions and summarize the keys learning. So uh, observations method. So here the questions: why do manas and pathis has have a circular basis? And now we begin our main activities. I would ask everyone simple questions. Have you ever noticed that traditional measuring container like mana, pati, bakari, or mauni usually have a circular base? Why are they circular? Why not square? Why not rectangle? Today we will try to answer these questions ourselves instead of directly giving the answer. We will use the observation methods. So in this method, we carefully observe the real life objects, discuss our ideas with group members, and finally connect our observation with mathematics. So specific in the objective of today's activities are very simple. The first objective is to identify the geometrical shape used in traditional measuring container, and second is we will relate mensuration concept to our daily life, and third is we will understand the relation between perimeter areas and volumes, and finally we will explain why traditional container like Manapathy are designed with a circular base. By the end of these activities, participants should be able to connect the mathematics with their own cultures and daily experiences. So, uh, now let me explain how today's activities will conduct it. So here, first participant will be divided into small groups. This will take about 2 minutes, and then each groups will observe the real objects or pictures of traditional container for about 5 minutes. After that, each groups will receive a rope and perform investigations. Using the same rope lengths, they will make different shapes like rectangle, square, and circle. Then groups will compare the areas of this shape and discuss their observation. Next, we will connect the areas with volumes and explain why this matters for the container. So finally, each groups will uh, present their findings to everyone. The activity flow or learning by doing approach where everyone actively participates. So suggested figure is this includes the jacket clothes, and then pakari, and then Mochka or Ghada. There are familiar objects that many of us have seen in our homes or villages. Instead of teaching the mathematics only from the textbook, we can use these real life objects in our classroom. So this also helps the preserve indigenous knowledge while learning mathematics concepts. So more cultural examples here. Here are some more examples such as Gundri farming lanes, like plot and Chambron. like this. So this example shows that the mathematics exist everywhere around us. For example, farmers use geometry while dividing lands, and traditional musical instrument also have geometric shapes. Similarly, woven mats like gundris involves the pattern and measurement, and by this design and by this container we also teach 3D and 2D concepts. So these examples helps student understand that the mathematics is not limited to the books. It is already part of our daily lives and our cultures. And in cultural integrations, so now let us discuss some important questions. Why are Moni's Dakia and Bhakkari circular at the base? And who designed this container? Did our ancestor actually have formulas like pi square? If they did not study modern mathematics, how did they create such efficient design? These questions encourage critical thinking, and participants discuss this question in groups. During the discussion, they realize that traditional communities learn through the observations and experiences, and then what is called that practices. So their knowledge was passed from one generation to another. These activities helps students respect indigenous knowledge as well, while also learning mathematics concept uh, too. So here is a possible concept. Now let us perform a single investigation. So suppose we have one rope so with a perimeter 40 centimeter. Using the same rope, so we mix three different shapes. First is rectangle, and second square, third is a circle. Then we calculate their area. We observe that rectangle has area 96 centimeter squares, may and may have the rectangle may have the areas like this, and the square has an area of 400 centimeter square, and then the circle has the largest area about 127.4 square centimeters. So this tells also something very interesting. When the perimeters is the same, the circle includes the largest area. Now let's connect these ideas with the container. Container are different dimensional objects, so their volume depends on the area of the base multiplied by the height. If all containers have the same heights, the one with a larger base area will hold some more materials, obviously, and that is one important reasons why many traditional containers are circular. So and now let me summarize what we learned. Then these activities include three different kinds of learning. The first is hand-on learning. So participant constructs shapes, measure them, and calculate areas and compare results. And the second is head-on learnings. So participants think critically and use mathematical reasoning to explain their findings. And the third is hot-on learnings. Participants appreciate their cultures and understand the wisdom of traditional communities. Now let us see how these activities integrate STEAM too. And in mathematics, students learn perimeter, area, and volume. In science, they learn pressure and stability. And in engineering, they will understand why containers are designed in certain shapes. And in technology, they see how traditional knowledge can inspire modern designs. There is also a science connections. Pressure is equal to the force divided by area. So when the base areas becomes larger, the pressure on the ground becomes smaller. Uh, and obviously circular container distribute weight evenly. So because of this, they becomes more stable and are less likely to sink or dip over. And Therefore, the circular shape is not only the mathematical efficient but also scientific practical. So now I would like to everyone to reflect on today's activities. Please think about these questions and uh, what new ideas did you learn today, and how did these activities help you understand mensurations better, and how can you use similar activities in your own classrooms? Please share your thoughts and experiences with the groups. uh, Reflection is important because it helps us connect today's learning with the future's teaching practices. Okay, thank you. This brings me to the end of the presentations. Thank you, everyone.